02 we will discuss about bootstrapping. Bootstrapping is the process by which simple language is used to translate more complicated program, which in turn may handle as even more complicated program and so on. And it is known as the bootstrapping. The compiler can be characterized by three languages: source language, target language, implementation language. It can be represented by the T diagram as follows: S for source, I for implementation, T for target language. So there can be a source language, and using that source language, we want to convert it into target language by using the implementation language I. In textual form, it can be characterized as follows: the three language S, I, and T can be quite different. All these three can be quite different. The compiler, such a compiler is called the cross compiler. Compilers are of two kinds: first, native compiler; second, cross compiler. Native compiler are written in the same language as the target language. For an example, SMM. You can see here the source language converted into uh, M language. Source language S is converted into M language by implementing the language M. Cross compiler are written in different languages such as the target language. For example, SNM. The N is the implementation language, source is the source language, M is the implemented language. So let us consider one example that we want to write a cross compiler for the language L in implementation language S to generate the to generate code for machine N. Existing computer compiler for S runs on different machine M and generates the code for M. So when compiler LSN is run through SMM, we get the compiler LMN. So here we have LSN and it is implemented by SMM and we get here LMM. So it can be represented diagrammatically like this. So it's very clear that this compiler code is compiled once on the SMMM to generate the compiler code in the language that runs on the machine M. So in effect we get the compiler that converts the language L to the code that runs on the machine N, and the compiler itself it is M. In other words, we get LMN. Suppose LLN is to be developed by a machine M. We take another example where LMM is available. So we can design like this. So there is LLN and we can use here LMM for the implementation part and LMN is the output. So if we compile LLN second time using the generated compiler, you will get like this. So LLN is now implemented with LMN, then you will get LNN. Using the technique desired, we try to use a compiler for the language L written in L. For this, we require a compiler L that runs on machine M and outputs code for machine M and output codes for machine M. So first we write LLN. We have a compiler written in L that converts the code written in L to the code that can run on machine M. We can compile this compiler written in L on the available compiler MMM. So we get the compiler that can run on the machine M and convert code written in L to code that can run on the machine N. So we get here LMN. So this compiler will now we again compile that original written compiler LLN to the new compiler LMN to go to the last step. So all these things can be implemented very easily, and we can have the final diagram. So this is the complete picture. Uh, so if we combine all those parts, so bootstrapping is obtaining a compiler from for a language L by writing the compiler code in the same language L. This diagram shows the complete diagrammatical representation of the process. Thank you so much.